An exponent simply means if you have a number 2, you multiply that to itself, 2, you get 2 cubed. 3 is the exponent. If I did 2 times 2 times 2 times 2 times 2 times 2, what would that equal to? 2 to the 6. Okay. 2 times 2 times 2 times 2, dot, 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 2. And I'm telling you I have X number of 2's. So what should go up here? X. So what you started as just numbers evolved into a function. A function y equals 2 raised x is an exponential function. Those who took algebra, do we know what the name for 2 is? Base. Exponent. If you like Megan Trainor, it's all about the base. So 2 raised x. X is the exponent, the base matters. So in general, we can write an exponential function as y equal to a raised x, where x is the base of the exponential function. Sorry, a is the base. And x is the exponent. X could be anything, but as I mentioned earlier, if x is fractional, i.e., let's say you have 1 over n or 1 over n, then when n is 2, you end up getting square root, n is 3, cube root, n equals 4, fourth root, etc. So we will start here and slowly go there. Good. Okay. I want you to do this. I want you to pick up your calculator. You can pick a value of a. Who wants to pick a value for a? Any number, but a reasonable number, between, say, 2 and 20. 11, okay. So pick up your calculator. Go to our usual graphing sport. I want you to graph 11 raised x. Okay, and tell us pass function. Okay, is that faster than full raise x? What else? Any other observations? Anything that strikes you as odd or fun, if you're a nerd. Fun for me, so Lily. Any other observations? Okay.
Both of the functions curve on the left side of the axis.
I know exactly what you're saying, but what do you mean by curve on the left side?
Starts negative.
Negative? You mean it's going down?
Now they go up.
So it's going this way, correct?
Yes.
So what is happening on the left-hand side? I'll draw, and perhaps one of you can help take that. Two curves, both of them would eventually go that way, right? That flattening part, what is it? Has a name. Starts with the letter A.
Asymptote.
Very good. Asymptote. What's your name? Mine. Asymptote. Both of them have asymptotes. What kind of asymptote are they?
Horizontal.
Horizontal. So they have asymptotes, but both of them look exactly the same. Agreed? In terms of the picture, the only difference being is one goes up faster than the other. Good? So by grow, we mean to say it is growing exponentially, hence the name, exponential function. What is that number right there? You can do trace. Or if you want to use algebra, when x is equal to 0, what is y? 1. So any number raised to the power of 0 is 1. So 4 raised 0, 1. 11 raised 0, 1. The intercept, specifically y-intercept, is 1. Good. If you haven't grasped, go ahead and follow my instructions. So the first one, we have 11. Raise x. The other 4 raise x. Just for fun, I'm going to look down below and see if there is a curve down there. It's not going to be. But let's adjust the window. Negative 10 to positive 10. One curve, another curve. One is faster, growing faster than the other. So that would be 11 raised x, the other one 4 raised x. Is there something over there? No. So what is the range?
Zero to infinity with parentheses.
0 to infinity with parentheses on both sides. Very good answer. Why parentheses right next to 0?
Because it's getting exponentially smaller.
But it couldn't reach 0. Very good. So last time I mentioned, anytime you have an asymptote, you're going to approach closer and closer to that value, but mathematically you cannot attain that value. So you're getting closer and closer to 0, but not equal to 0. Good. What is the domain? What are all the possible values that you can put in for x?
Negative infinity to positive infinity.
Very good. Negative infinity to positive infinity. And from last time, and the time before, anytime you have negative infinity or positive infinity, you don't put brackets. If there is an answer, this class, future classes have infinity and someone put a bracket right next to it, that is the wrong answer. Dead giveaway. Good? Are we clear? So, does that mean that an exponential function can only go up? In other words, grow? Yeah, it can only go up. Yes or no? In other words, can it go down? Corbin? It can't. How do we make it go down?
You take the Do you make the exponent negative?
Okay, so correct. Instead of say 4 raised x, if I wrote it 4 raised negative x, goes downwards. Good. We will address this later as decaying or decreasing and increasing exponentials. In terms of a graph, both a raised x for any value of a and a raised negative x are exponential functions. One is growth, other is decay. Good. There is one thing that you'll see time and time again in math, is e right there. Can someone tell me what that is?
I just know the value is like 2.7 something.
781.
782.
It's just a constant, it's not a constant. It is an irrational number, unless you end up being, in math, or stars, in the future, you won't probably see it again. Two common possibilities for the base value a. You can either pick 10 or you can pick e. 10 is decimal base. E, natural base. Why do we call it natural? That's what we use in math for all natural numbers, etc. Without getting into too much detail, E is the natural base, 10 decimal base. 10 raised x is what we use in our daily lives. 10 raised to the power of 0 is 1. Do we like money?
Yes.
Yes.
Louder. No enthusiasm. Who doesn't like money? I do. Okay. 10 raised 0 is 1, correct? $1. 10 raised 1, $10. 10 raised 2, $100. 10 raised 3, $1,000. So if you go back to the ancient mathematics, going in powers of 10 was easier. People liked it, which is why we have that currency system. So powers of 10, decimal system, exponential, e raised x, natural system is what we use in math. There are others, we won't talk about those in this class. Are we clear? Okay.